All right. We have the mean value theorem. The mean value theorem is f of b minus f of a over b minus a is equal to f prime of c. And what that means is if you have a function that is differentiable and continuous over the interval a to b, then, and if you were to draw a line or a segment that represents the average rate of change over that given interval, then there is some point c in the interval ab such that the line tangent has the same slope as that segment. So that's the mean value theorem. We do 2 problems today, then you're going to be able to work on your worksheet. So the examples we want to look at today involve sine, and then we have a radical problem. So I'm going to plug it in, take all your calculators. Yeah. Okay, so I'm going to go to the table, and I'm going to type in 0. I'm going to type in 3 pi. And you can see that for 3 pi, you get negative 3. So f of 3 pi is negative 3. And then f of 0 is 0. So I'm going to find the mean value, or the average rate of change, by taking f of b, which is negative 3, minus f of a, which is 0, divided by b. I get negative 3 over 3 pi, which is negative 1 over pi. What did I just find? On my slope. So if I write my equation for my line tangent, I got slope is negative 1 over pi. And if I do my point on my line, I need an x value and a y value. How do I find that y? How do I find the x value? Take the derivative and say equal to negative 1 over pi. So what rule do I have to use for the derivative? So I set up 3 what? 3 sine of u and 1/2 x. Derivative of 1/2 x is 1/2. Derivative of 3 sine of u. 3 cosine of u. So I have 3 over 2 cosine of x over 2. I'm going to set that equal to negative 1 over pi. How do I solve that? I could take negative 1 divided by pi, and I'm going to multiply that by what? 2/3. So I get cosine of x over 2 is got it. Cosine of x over 2 is equal to negative 0.21. So let's consider this situation right here, okay? How do I get rid of the cosine? I inverse. Now, let's go back to our trig from last year. Where is cosine negative? The left. Okay, and if you remember, this is 0. This is 3.14. This is then 1.57 because we're working in radians in this situation. So I know I'm going to be, and you could come up with 2 solutions. Anytime you get a trig problem, I'm just going to ask you to come up with one of the solutions. I didn't work out the interval, so you only come up with one. So okay, so let's just find this first solution. I do cosine inverse, and remember, you can include the negative or you could choose not to. It doesn't matter. Either way, you got to try to figure it out. 1.78, does that bring me to the second quadrant? Yeah, if you wouldn't have included the negative, if you would have done cosine inverse of 0.21, then you would have taken 3.14 and subtracted the 1.36 from it. So So our angle is 1.78 radians. So I end up with, the cosine is gone, what's left? X over 2 is equal to 1.78. And now I multiply 2 times 1.7846, and I get 3.57. How do I find my y value? Plug it into the original, so I go to my table, 3.57, and I get 2.93. Now I'm going to write my equation for the line tangent, y minus 2.93 is equal to negative 1 over pi times x minus 3.57. Negative 1 divided by pi times negative 3.57 plus 2.93. So I've got y equals negative 1 over pi times x plus 4.07. Now here's what I was trying to show you yesterday I forgot about. If I go back to my y equals, and here I type in the equation for the line, which is negative 1 divided by pi, and I multiply that, or let's see, times x plus 4.07. If I go back up to my original equation, and I want to just see, again, the interval from 0 to 3 pi, I don't put the comma in there. I just go parenthesis, x, and go to the test area, number 3, greater than 0, parenthesis, and then another parenthesis, x, and now we want to go less than 3 pi. So I grab the less than sign, which is 5, and 3 pi. So that will graph the piecewise function for us. And it's really cool how this is displayed. First of all, the window, what's the, our sine function, what's the amplitude? What's the amplitude of our sine function? It's 3. So I'm going to go a y min and max of negative 4 and positive 4. And then the period is going to be 2 pi divided by 1/2, or 4 pi. So if I go all the way out to 4 pi, negative 4 pi, and then positive 4 pi. We'll put a tick mark every pi. Watch my graph here. I think this is sweet. So it's just going to graph the sine function from 0 to 3 pi. It gets a little crazy there at the end. And then it draws the equation for line tangent. So here's what's really cool is if you were to draw a segment from its start to its end, would that be parallel to what's shown there? And that's how we verify our answer. And so you might be like, do we have to do that? Well, you don't have to, but the whole idea is that you can sketch that graph, and that would be meaningful to you for that purpose. Because you guys, when I make up these problems, how do I verify that they're correct? I do this. You know? I do that to make sure that it matches up. That's how I know that I did it correctly. Okay? All right. One more, and we'll head to lunch. You start setting it up, I'm going to get a test. Okay, so you got slope is 1/2. You got 2u to the 1/3. Derivative is 2 over 3u to the 2/3. Because the 3 will come to the denominator and do the 1/3, and you subtract 1 from 1/3, you get 2/3. It's negative, so it goes to the denominator, and derivative is 1. So we got f prime of x is equal to 2 over 3 times x minus 1 to the 2/3 power. We're going to set that equal to 1/2. How do we solve that? Cross multiply, so you got 4 is equal to 3 times x minus 1 to the 2/3, divide by 3. And now we get to this part. Right, so you guys both have the right idea. So we got two things here. Number one, we need to cube both sides to get rid of the third root. We need to square root both sides to get rid of the squared. Or in other words, if you want to get rid of an exponent, you raise it to the reciprocal power. So we got x minus 1 is equal to, and 1.54 to the 3/2 power. Make sure you put that 3/2 in parentheses. If you take 4/3 and you raise that, then you have to make sure that you put the 4/3 in parentheses too if you list the whole thing, because you want the fraction raised to the 3/2 power. You can see that you get the 1.54. Add the 1, you get 2.54 is equal to x. So we have 2.54 as our x value. How do we find our y value? So I'm going to go back here. Here's another way to do it. X minus 1 raised to the parentheses 1 divided by 3 power. Otherwise, you could grab the cubed root from math. Either way, you could get it by going to my table. I type in 2.54, and I get 2.31. So I got y minus 2.31 is equal to 1/2 times x minus 2.54. And we'll finish up when you get back. I'll just show you the graph. We'll be done. Go get some brain. Okay, we're going to write this equation for the line, then we're going to plug it in. You guys got time to work. So, got y is equal to 1/2 x. What up, G? We're going to take 0.5 times negative 2.54 plus 2.31. And I get 1.04. So let's verify our answer is correct. We're going to plug it in right here. I got 0.5x plus 1.04. And then I'm going to go up here and I'm going to restrict the domain. This is my favorite part. Yes, it is. I'm going to grab x. We're going to go greater than what? What's our lower domain value? 1. So I got be greater than 1. And then I'll set up another set where we go x is number 5 less than 9. Look at this. Oh, I'm not going to see the whole thing, though, because I got to change my window. Okay. Oh, I guess I do. So there you go. So again, you can see that it has trouble with the very last value, but if you were to make a segment that connects those two together, it would be parallel. Not practically, it would be exactly parallel. So there we have it. Oh, gosh. All right, so your worksheet. Finish it.